This video is brought to you by IXL, used by millions of students worldwide to get ahead in math, English, and more.
Let's learn about the Intermediate Value Theorem. The Intermediate Value Theorem tells us that for a continuous function on some interval from a to b, the function will have to hit every y value in between the y value at x equals a and the y value at x equals b. This makes sense because if we look at a graph, there's no way to connect f of a and f of b without crossing every value in between, unless we draw a graph that's not continuous. More formally, if f of x is continuous on an interval from a to b, then f of x takes on every value between f of a and f of b for at least one value of x in ab. Let's practice applying this theorem in some examples. Here's our first example. We are told that the function p is a polynomial, and that p of negative 9 is 1, and p of negative 3 is negative 10. We want to know if p of x is ever equal to negative 7. Okay, to use the intermediate value theorem, we need to verify that the function is continuous on the interval we're interested in. Polynomial functions are continuous for all real input values, so p is continuous on the interval from negative 9 to negative 3. That means that p of x takes on every value between p of negative 9, which is 1, and p of negative 3, which is negative 10. The y value negative 7 is here, in between negative 10 and 1. So the intermediate value theorem does guarantee that p of x will be equal to negative 7, somewhere in the interval from x equals negative 9 to x equals negative 3. The graph could look something like this, or this. But in order to get from y equals 1 to y equals negative 10, it will have to pass through y equals negative 7, since it is continuous. Here's our next example. The table shows certain values of f of x on the interval from negative 11 to 19, and we are given that f of x is continuous on this interval. Let's determine if f of x equals 0 has a solution. Let's look at a graph of these points to help us visualize the problem. I notice that all of these points are above the x-axis. In the table, all of the y values are positive. So while the graph could possibly touch or cross the x-axis, like this, it could instead look something like this. So it's not guaranteed by the intermediate value theorem that the function will cross the x-axis. Let's consider this more formally. Since f of x is continuous on the interval from negative 11 to 19, we know it's continuous between any two x values in the table. We see that f of negative 11 is 2, which is the lowest output in the table, and f of 9 is 9, which is the highest output in the table. So the intermediate value theorem tells us that on the interval from x equals negative 11 to x equals 9, f of x will take on every value between 2 and 9. Since 0 is not between 2 and 9, there is no guarantee that f of x will ever be equal to 0. Nice job here! Let's try one more together. The table shows certain values of g of x on the interval from 6 to 10. G of x is a polynomial, which we know means it is continuous for all values of x, and we want to see if g of x equals negative 2 has a solution. We see that g of 10 is negative 11, which is the lowest output, and g of 7 is 12, which is the highest output in the table. So we know that g of x will take on every y value from negative 11 to 12 on the interval from 7 to 10. The value we're wondering about, negative 2, is between negative 11 and 12. So the intermediate value theorem does guarantee that f of x equals negative 2 has a solution for some x value between 7 and 10. Great work on these examples. You're ready to practice using the intermediate value theorem.
Head over to IXL.com for more practice on this skill and thousands more videos in math and language arts.